5 minutes or something.
Okay.
So let's some other person to join, and we'll be starting. And today actually we'll be discussing about the uh, 27 like remote sensing and image interpretation. So today is your block unit 4, that is about DIP. So we'll be discussing on that. अमित कुमार म्यूट करो बहुत, ये साउंड आ रहा है. ओके, थैंक यू. And actually from tomorrow onwards you will be having classes on GPS along with GIS. What is GPS and how it works, and in coupled with GIS, how GPS works, all that, and it will be covered by our colleague Mr. Satyaranjan Giri. So up to 10th of September classes will be there, and I'll be taking classes on 11th September. So in this month, today is my last class, and surely we'll be discussing on 11th only in September. So आप लोगों को कैसे मतलब हाउ नाउ, ये जो कुछ क्लासेस हो गया ना, तो हाउ यू पीपल फील कि रिमोट सेंसिंग जीआईएस इट इज़ आप लोगों के लिए, वेदर इट इज़ यूजफुल, और in which sense actually you are going to you are planning to utilize in your career, and for commercial use or whatever, R&D and some other parts also. So I would like to listen from anyone, like Amit. How do you think whether it is useful for you or not? हाँ भाई अमित, आप हो या नहीं?
Yes, sir.
कैसा लग रहा है जो कुछ 10-15 दिन से हम जो रोज शाम को जो है दो 1-1.5 घंटे 2 घंटे बैठते हैं, तो इसका कुछ फायदा होने वाला लग रहा है या नहीं?
जी सर, पहले से तो ठीक लग रहा है सर.
लग रहा है सही ना?
जी.
अच्छा. और एंड्रयू, व्हाट इज योर व्यूज ऑन दिस?
Yes, sir.
व्हाट इज
Sir,
योर व्यूज?
yeah, it's very useful for learning remote sensing and GIS. For and future, I have a good job and some research. Anyone want to do PhD means it's very useful to remote sensing techniques and some GIS aspects.
Yeah, actually nowadays now in every sector, if you are having an uh, knowledge on the spatial science, then definitely it gives an additional weightage to your career perspective.
Yes, sir. So
Uh,
nowadays, health sector also using for GIS and
everywhere you can say, for example, health or your real estate,
yes, sir.
whatever, anything you can name, and definitely directly or indirectly they are using this domain. That's
Yes,
why,
sir.
and you can't believe that now the doctors, they are also getting training from IRS Dehradun or some other uh, national institution in order to enhance their capability in RSJS. So surely, and not only in government sector but privately also there is a good opportunity, I can say.
Yes, sir.
uh, so okay, so let's start. Just a minute. Slide is visible. Anyone please respond. Andrews, whether my slide is visible to all of you?
Yes, sir. Visible, sir.
Yeah, okay, fine then. Let's move. So today I will be discussing in depth about digital image processing. No doubt this particular your MGY-102, it is meant for remote sensing and image interpretation. So in our last three classes, including classes taken by Mr. Giri, we talked about sensor and some space program and about some visual image interpretation, and also we talked about some signature resolution. So these are the topics that were covered by us. And today class, this is your unit 4 of this MGY 102. So we'll be discussing more about the image interpretation part, not the like the digital image interpretation part. Today we'll be discussing. So there are some difference in visual image interpretation technique along with this digital image processing. So in visual, what is happening? In visual, we are using different type of like tone, texture, color, and so many other aspect. While we are distinguishing a different type of features on the art surface. जो image में what are different features are there. So we are trying to group them or we are trying to differentiate them. So for that purpose हम यूज करते हैं टोन, टेक्सचर, कलर, शेडो एंड सो many image interpretation keys. But in digital image processing, what is happening? Instead of using those things, what we are doing, we are utilizing some processing things are there, like some models are there, or maybe for a image classification, we are going for a supervised, unsupervised classifications are there, and any satellite image before it is being used by a common man or suppose a remote sensing technician or a GIS technician or GIS expert, it goes through some process, or it is done by the image analyst or those person who are like an image scientist, I can say, or remote sensing scientist. So see, remote sensing and GIS, they both are interrelated to each other, but in remote sensing they deal with mostly on the satellite image. But GIS, what we are doing, we are basically interpretation, we are doing the interpretation of those satellite image, and we are doing the analysis, and we are finally we are preparing some maps for different type of visualization and analysis purpose. So now I'm changing to the next slide. Here you can see that it's like introduction to digital remote sensing images. Here the remote sensing images captured about the earth surface from a distance. It is known to you we are having a satellite image, the satellite sensor are there and they are capturing the electromagnetic radiation that is reflected or emitted by the object on the ground में whatever features are there वो emitted होके और reflected होके जो हमारा सेंसर होता है, सेंसर इसको कैप्चर करता है. So this is the basic I can say the basic principle of remote sensing. Okay. So next also we have discussed about some resolution, but here I've taken the higher the resolution in terms of spatial. So suppose you are having an image which is having a very high resolution it is having, then you will be very it will be easy for you to distinguish the different features in a accurate manner. But in the same time, if you are having a low resolution of low spatial resolution, then some features like very large feature like a forest, mountain, river, it is easy to differentiate instead in spite of a low resolution. But अगर ज़्यादा information चाहिए, if you need more information, then obviously the high resolution satellite image is required. Then here about the spectral resolution and multispectral resolution is there. In spectral resolution, what we deal with? We deal with different spectral bands. कितना bands ज़्यादा है, तो उसको हम we call it multispectral. Then how it can be used, like identification of minerals and all. Then so it's about radiometric resolution. In radiometric resolution, what it is meant for? It is meant for the whether it is a high radiometric resolution image is there, or it is a low resolution images in when radiometric things are concerned. But Uh, Actually, I would like to clarify here why I am giving you some glimpse of this resolution, because earlier we already talked about this resolution and all, but as today's class it is based on mostly on image based analysis. That's why I was trying to make you a one type of recap about different type of resolution. Then fourth one is like temporal resolution. It is based on the time basis or time period. So basically the resolution is divided into four types. First one is spatial, then spectral, radiometric, and finally we have the temporal resolution. Okay. So in next, ये इसको छोड़ दो, ये इसको भी छोड़ते हैं, because we already know about the what is active and what is passive remote sensing. Then here ये थोड़ा सा आप लोगों का काम का है कि लाइक ज्योमेट्रिक डिस्टोर्शन आर देयर इन आवर सैटेलाइट इमेज. वी हैव सम distortion, that means कुछ errors are there when acquiring images from satellite or aircraft. So in image processing what we are doing, we are modifying or we are correcting those errors so that we can get a good satellite image or a image having a good quality or accurate information can be acquired. In this slide you can see some pre-processing and enhancement technique. Like whenever we are going to use a satellite image, it, it has some errors in terms of some atmospheric errors are also there. What can be like? Suppose clouds are there, so we need to remove those cloud cover. Haze is there, and so many other small uh, corrections are there, which is some errors are there that is need that errors needs to be rectified. So we use those some techniques. We use some technique to rectify these errors caused by the atmospheric particles, or it may be caused by some mechanical things like the sensor and some other. And here in this slide you can see like what are the fundamentals of digital imaging. Like we used to learn about the pixel, how a pixel is there and how a different pixel they represent different information. Then we will be talking about the image resolution. Then different type of formats are there that is used in image processing, like JPG is there, PNG is there, TIFF is there, GeoTIFF are there. So many formats are there which is used in DIP, image processing. I am just keeping some slide. Just a minute. I'm going to your this one. This is your syllabus based. This syllabus start from here only. So here we'll be talking about the digital image interpretation and what are the characteristics of digital remote sensing images. Images का क्या क्या characteristics होता है. Then what are the methods and technique are used in digital image interpretation. जो digital image interpretation हम करते हैं, so how we do it and what are the methods available or what are the techniques are available for the digital image interpretation. Then we will be talking about some image pre-processing. Then we will be going for some image classification. Image को कैसे classify करना है, whether it is a supervised classification or it is a unsupervised classification and so other. And finally, after being classification, what are the post classification methods are there. So these three things we are going to learn. First one is प्री प्रोसेसिंग. एक इमेज को यूज करने से पहले क्या प्री प्रोसेसिंग हम करते हैं. देन उसको कैसे हाउ वी डू इट द क्लासिफिकेशन, और उसको क्लासिफिकेशन के बाद हम क्या करते हैं. तो ये बेसिकली तीन चीज है. उससे पहले हम डिस्कस करेंगे कुछ टेक्निक्स कैसे इमेज इंटरप्रिटेशन करते हैं. ठीक है. तो यहाँ तक कुछ अगर किसी को कुछ कहना है या फिर कुछ कहीं पे अगर आप फील करते हो कि यू नीड टू ऐड समथिंग or maybe something skewed by me, then you can ask me here. Like मनीष कुमार जी, आपको कुछ कहना है क्या यहाँ पे, या कुछ ऐड करना चाहते हो?
नो सर, थैंक यू.
नहीं, क्यों? अरे पूछो ना भाई, कुछ पूछो. ये और कोई है अपना Manjit ji, do you want to speak something?
No, sir.
No, it feels you are tired with your work or something. No. Okay, then Yasna ji, do you want to speak something or no? चलो ठीक है अभी so here first of all we should know what is an image. So basically image क्या है कि it is a like it is a constellation of different type of pixel. So pixel is a very small unit of an image. So in image में क्या होता है कि there is an range of like different coordinates are there, like x y coordinates are there. In any pixel it is having a particular coordinates. The latitude longitudes are there, then they are arranged in a range of x and y. So in our coming slide you will be knowing एक सैटेलाइट इमेज है, सैटेलाइट इमेज में हाउ डज इट लुक्स. अब देखिए ये नेक्स्ट स्लाइड जो है यहाँ पे, whether it is visible to you, anyone please clarify. This particular one pixel image is there and the right hand side some values are there. आप लोग कभी काम किए हो ना सैटेलाइट इमेज में तो आपको पता होगा कि जब हम उसको ज़्यादा जूम करते हैं, when we enlarge it to the maximum level, at that time आप देख सकते हो कि इट्स लाइक सम पिक्सल आर देयर, स्क्वायर स्क्वायर होता है ऐसे पिक्सल. तो एक एक जो आपका पिक्सल होता है, ईच एंड एवरी पिक्सल दे कंटेंट सम इंफॉर्मेशन. तो उसको हम क्या है डीएन वैल्यू बोलते हैं, डिजिटल नंबर बोलते हैं. तो यहाँ पे जैसे इन हियर यू कैन सी दैट for 16 number of pixel are there, and in 16 number of pixel, each pixel they indicate some values. The pixel values are there, dn values are there. ऐसे होता है एक आपका क्या बोलते हैं, आपका एक सैटेलाइट इमेज में इस टाइप का होता है. देन हियर यू कैन सी दैट टाइप्स ऑफ डिजिटल इमेज. इसमें क्या है कि इट कैन बी ए ब्लैक एंड वाइट इमेज हो सकता है, और ये एक ग्रे स्केल हो सकता है, लाइक मोनोक्रोम इमेज हो सकता है, और कलर हो सकता है, या फिर रेड ग्रीन ब्लू तीन जो आपका बैंड है ये कॉम्बिनेशन में भी इट कैन बी हो सकता है. सो आपका ब्लैक एंड व्हाइट में क्या है कि आपका इसमें 0 से 256 तक होता है डिजिटल नंबर डीएन वैल्यू. तो इन बिटवीन दैम जो हमारा व्हाट एवर जो अर्थ का फीचर्स है दैट इज रिप्रेजेंटेड. अर्थ का फीचर जो है ये 0 से 255 के रेंज के बीच में ही आता है. देन मेथड्स एंड टेक्निक. नाउ अभी क्वेश्चन आता है कि जो व्हाट एवर सैटेलाइट इमेज आर देयर विथ अस, सो उसको इंटरप्रिटेशन करने के लिए व्हाट टाइप ऑफ टेक्निक्स वी यूज, क्या क्या टेक्निक हम यूज कर सकते हैं, उसके बारे में वी आर गोइंग टू डिस्कस. एंड आई कैन से दैट व्हाट आर द एडवांटेज ऑफ डिजिटल इमेज प्रोसेसिंग. वन एग्जांपल इज लाइक इट्स data storage can be done very in a quick manner. Then visualization with great details of the features. Then quick and efficient web data extraction में. Then some like it can be like suppose you are having a cloud is there, cloud image is there. So if you are using the image processing application, then those errors can be rectified by using the digital image processing technique. Then in this slide you can see, I don't know whether it is visible to you or not. So here different type of steps are involved when digital image processing is concerned. Okay, anybody can you explain ki can you name any two software that deals with satellite image processing काम में क्या क्या सॉफ्टवेयर यूज होता है? एनीबॉडी आपको आइडिया है और कोई काम किया है इसके ऊपर?
सर इमेज प्रोसेसिंग में आर्क मैप हो गया, एडास हो गया, ये सॉफ्टवेयर यूज होते हैं ना?
नहीं, आर्क मैप जो है वो बेसिकली वो जीआईएस का है, बट आजकल दे आर कॉन्फ़िगर्ड विथ इमेज
Sir,
प्रोसेसिंग।
actually,
स्नैप,
uh,
सर स्नैप।
स्नैप को तो स्नैप में ज़्यादा
sir,
कुछ नहीं
AJ
होता है।
soft.
बट आपका जो एनवी है और एडास है, इसको हम कह सकते हैं डेडिकेटेड इमेज प्रोसेसिंग सॉफ्टवेयर हम कह सकते हैं। नो डाउट आरजीएस में बहुत सारा आजकल फीचर्स आ गया है जो कि हमारा जो इमेज प्रोसेसिंग के लिए इट्स एनफ। बट अगर ज़्यादा एक्यूरेसी चाहिए तो देन वी शुड गो फॉर dedicated image processing software like for example ADAS, NV and ILVIS is also there, जो भी एक आपका इमेज प्रोसेसिंग सॉफ्टवेयर है। तो
Rajesh sir,
अगर
sorry.
हाँ
Hello.
हाँ मनीष जी
Sir, I
बोलिए।
think AJ soft भी यूज होता है ड्रोन इमेज प्रोसेसिंग के लिए.
थोड़ा आपका
ठीक
आवाज़
है.
ठीक से सुनाई नहीं दे रहा है, क्या बोल रहे हैं?
मैं कह रहा हूँ सर AJ सॉफ्ट भी यूज होता है.
अच्छा।
AJ सॉफ्ट.
हाँ, नहीं हो सकता है क्योंकि अभी जैसे आपने बोला कि यूएवी के बारे में, तो ड्रोन टेक्नोलॉजी जो यूएवी जो है ना, इसमें क्या है, उसको प्रोसेसिंग करने के लिए भी हम वी यूज डिफरेंट टाइप ऑफ सॉफ्टवेयर। और आजकल हर एक दिन में मतलब हम कह सकते हैं नए नए सॉफ्टवेयर सब आ रहे हैं। और आपका ये जो एआई एमएल जो यूज होता है तो आजकल बहुत इजी है डिफरेंट टाइप ऑफ एप्लीकेशन डेवलप करने के लिए। बट अगर हम ऐसे बोले कि जो ट्रेडिशनली और जो अच्छा रिजल्ट देता है ऐसे कुछ सॉफ्टवेयर इमेज प्रोसेसिंग का अगर एग्जांपल बोलते हैं तो उसमें से आपका ये एनवी एडास ये सब अच्छा आउटपुट देता है। और
ओके.
एक बिग डाटा, ज़्यादा कुछ डाटा है ना, जैसे एक टोटल स्टेट का है कुछ, अगर आप प्रोसेस करते हो, सो इन दैट केस एनवी और एडास ये सब अच्छे मतलब आउटपुट देते हैं। ठीक है। अभी अ, अभी कुछ स्टेप हैं, जैसे आपका आप इमेज करेक्शन कर सकते हैं, या फिर एक इमेज प्री प्रोसेसिंग होता है। कुछ काम करने से पहले वी नीड टू हैव सम प्री प्रोसेसिंग वर्क, देन हम उसको क्या करते हैं कि इमेज को एनहांसमेंट करते हैं। मे बी ब्लरिंग है या कुछ अलग प्रॉब्लम है, देन वी शुड गो फॉर सम एनहांसमेंट। देन in some cases which we use some transformation process, then we can go for image classification, so it may be supervised, unsupervised, whatever. Then suppose after doing all this like classification of image, we feel that there is some error, it may be there. So for that purpose we should go for the accuracy assessment. So we in accuracy assessment what happened, we evaluate ourselves. Suppose I am given with a district of Maharashtra. Okay, I am given a district of Maharashtra, but I belongs to Odisha. So suppose that particular area, I am not acquainted with that area, मुझे उसके बारे में इतना पता नहीं है। ठीक है। या फिर one person is he is from UP, and or like someone from Jammu Kashmir or a hilly state of northeastern or somewhere, and he has been assigned to a area of coastal area, like for say example West Bengal, Odisha, Kerala or something else. Then the features that prevails on the coastal area, it is totally different from a hilly region. So at that time that person uh, may face some difficulties in doing the classification. So for that actually we do some error, and that errors needs to be modified or needs to be rectified. In that process actually we do some accuracy assessment. Okay. So actually in some our coming slide we have some slide which represent about the accuracy assessment, and also some prominent calculations are there, right from kappa coefficient, where we have a like two columns will be there, like a producer accuracy is there, whatever you have done in your lab, and after going to the ground truth collection, you should go for how far you are correct. Suppose you are getting an accuracy of more than 90%, then we can say that yeah, it's correct. But that ground truth collection is also play a very vital role, because mm, we don't know, we are sitting in our lab and we are seeing that this is a swampy area, or this is a grassland or scrubland or something like that. But in field we do not know whether it is there or not. So for that purpose we need to go to the field, and we need to go there and we have to collect the what your coordinates point of that area, and After that, that coordinates has to be superimposed on our satellite image, and then again we can say that yes, we did it as a scrubland, but in fact it is a swampy area. So in that purpose, our interpretation is going to be enhanced, and we are going to get a good output, because in some project or some assignment the accuracy play a very vital role, and we need to focus on that. Okay, so some like broad step in remote sensing data processing, like acquisition of satellite data, then pre-processing of those data, then analysis of satellite images, then in the some product we are getting, then its application on the field or its end user, how we are going to implement those application. So these are the some steps that we follow mostly when your image processing is concerned. Then here in this slide you can see one example is about your image enhancement, another one is for your image transformation. So first of all, I will be talking about the image enhancement. So in image enhancement, what happened, we are simply, this is the technique which is used to increase the human interpretability or ability to derive meaningful information from remotely sensed images. That means, suppose you are provided with a colorful image, and another one is provided with a black and white or panchromatic images. So it totally depends on your expertise, your knowledge on that field, ki how you are going to distinguish or differentiate the different features on the earth surface. अगर सपोज हमारा जो है यहाँ पे आपका एंड्रयू जो है, एंड्रयू को लगता है कि ये पर्टिकुलर इमेज जो है ये एक ग्रासलैंड है, उसको लग रहा है, बट मनीष को लग रहा है कि नहीं नहीं ये ग्रासलैंड नहीं है, ये थोड़ा सा बड़ा बड़ा पेड़ है या फिर वेजिटेशन आपका कुछ वेजिटेबल है, ऐसा लग सकता है. तो इट टोटली, बिकॉज वी आर नॉट गोइंग देयर ना, वी आर जस्ट सिटिंग इन आवर लैब एंड वी आर डूइंग द इंटरप्रिटेशन. तो उसमें क्या है कि देयर इज ए चांस दैट वी आर गोइंग टू मेक सम एरर. तो अगर ऐसा एरर होता है, सो इट कैन हैव ए नेगेटिव इम्प्लीमेंटेशन, उसका बहुत रॉन्ग ये हो सकता है. दैट्स व्हाई always keep in mind that suppose something is like doubtful area is there, then just note it down, the coordinates should be noted down, then you should go to the field for the verification and I can say the validation purpose. Okay, and in the middle you can see one image transformation. Here what happens, where it involves some manipulation of multiple bands from one single multispectral image to some other. Like in here I have given some example of Landsat 7 false color composite image of a Himachal Pradesh, and before and after normalized difference vegetation index. See, in the left hand side you can see it is a satellite image of Landsat 7, and so that, see how I am going to transform it, because for example in that my what original image, in that image I am having a 10 numbers of band. Okay, see, for example, it may be a near infrared, it may be a visible range, it may be a red, green, blue, or near infrared, and so many bands are there. But I am not interested in all bands. Okay, suppose I am interested in the vegetation cover from that satellite image. I am interested to get the only vegetation, कहाँ कहाँ पे vegetation है, उसी चीज को ही मुझे extract करना है, मुझे निकालना है. Okay, and on the other hand, some other person is there who is interested for only water body, उसको only water body को ही निकालना है और बाकी चीज में उसे मतलब ही नहीं है. Okay, so in that case, two person they are going to use different methodology. Okay, or different bands has to be used by them. See, for example, X is interested in the vegetation, then he will be using or she will be using the NDVI, so normalized different vegetation indices. In that she will be interested in only two bands, that is NIR, that is near infrared, another one is IR. So NIR minus IR divided by NIR plus IR. This is the standard formula or standard formula. By utilizing those formula, we can get the output as only vegetation cover are going to be extracted. But some other person who is not interested in your vegetation, then suppose he is interested or he is interested for uh, extraction of built up index or water index or maybe moisture index, so many indices are there. Okay, so for that she is going to use some other bands. Okay, so this is the image transformation, and here you can see some merits and demerits of supervised and unsupervised classification. I think in our next some slide, there is a description about the supervised and unsupervised classification. But very briefly, I can say that unsupervised classification is that suppose I am not acquainted with an area, and what I am doing, I am giving the instruction to the software that please divide my total area of interest into 15 number of classes. So what it will do, it will classify the total area into 15 numbers. Okay, but in supervised classification, what happened? We need to give instruction that this particular pixel represent water body. मुझे लगता है कि ये water body है. Then I will assign that pixel as water body. Then another feature is there. Suppose the vegetation is there, so I am assigning that pixel as vegetation. So and so on. I am giving like 15 or 20 numbers of a signature. We say it's signature. Then based on that input given by us, the what system will do? System will classify the total area into on the basis of that signature. So this is the difference between supervised and unsupervised. Supervised means we are supervising, but in unsupervised we are not supervising it. We are just giving the classes, and the your software is giving us the output. So merits are there. Like in supervised classification, analyst has the control over the classification. हम खुद control कर सकते हैं. और processing it depends on known identity. आपको कितना आता है. Then errors can be detected and often rectified. ये कुछ merits है supervised के. और unsupervised का क्या है? No extensive prior knowledge. जैसे मैं बोल रहा था, we don't need any prior knowledge of that area. We're just giving those commands and it will be classified on that basis. And what are the demerits? Demerits are like for supervised classification, analyst or the person impose a structure on data which may not or which may match or do not match. It again depends on our expertise. Suppose I am not an experienced person, I am classifying a water body as a like forest, then definitely it is going to hamper my like result. That is one aspect. And in demerits part for unsupervised classification, like analyst has a little control over classes. So whatever output that you are going to get, it will be done mostly by the system. So these are some supervised and unsupervised classification. Then here what I was talking about your accuracy assessment. So in accuracy assessment, what I was discussing, whatever is done by us in our own knowledge, this is going to be validated when accuracy assessment is concerned. Again, some important thing is that in order to do a good accuracy assessment, we need to compare two sources of information. That may be, it may be some interpreted map are there, some classified image are there. So we need to compare them in order to get a good result. Then we need to have some reference map, we need to have some information on ground truth data, and in some case also we need to merge the resolution. Like we are having a colorful images there and we are having panchromatic image, so we need to go for the resolution merging so that we can get a good or accurate classification. And we should have the error matrix that describe the comparison of these two sources of information. आपका एक रेफरेंस इमेज है और आपका एक क्या है, आप ग्राउंड ट्रूथ में गए हो, ग्राउंड ट्रूथ से जो इन्फॉर्मेशन लाए हो, सो it can give a error matrix. So how far you are correct? Then some like statistical based like kappa coefficient kappa coefficient mostly I can say it we use it kappa coefficient for the measurement of like error or in order to derive a error matrix we use the kappa coefficient method. Then here earlier as I was talking about some image process pre-processing, then some classification are there, then in the last some post classification. So here in this slide we are going to talk about the image pre-processing method. So in image pre-processing method what are there? Image correction, we should go for image correction. Then in some cases we can go for some image enhancement and image transformation. So it may be like some in image correction it may be geometric correction. In geometric correction what we are going to do for different type like systematic distortion it may be there, then non-systematic distortion. Then in radiometric correction again it may be a systematic or non-systematic. I'm not discussing in detail because see these are all like practical based things, so just you should know very a brief idea about what is happening in pre-processing, post and other image processing things. But we need to uh, work on the uh, like some image processing software so that you will be knowing it in a detail. And again in while we are doing the image enhancement, so it may be some point operational or it may be contrast enhancement and also local neighborhood or spatial enhancement, and so many other techniques are there that we follow during our image enhancement technique. Then second one is like image classification that we have talked about different classification scheme, like it may be supervised, unsupervised classification. Here also something is that in supervised classification this process we are giving uh, the system a training data, and based on that actually it classify. Then what are the stages involved in supervised classification? It's like giving the training set. हम training set देते हैं कि ये क्या है ये क्या है, and that basis it runs the model. Then signature evaluation करते हैं, we are evaluating the signature whether it is correct or not, like that. Then finally we are taking a decision that no, this is the correct whatever is given by me. In that things we need to have a discussion with our our boss, or maybe to whom we are discussing, the team lead or something, some senior, so that I am giving this or I am classifying this as a water body. Then at that time if a person who is experienced person can give us a good idea, no, actually you are doing a wrong thing. So before assigning the final signature we need to have some discussion and we can go for the decision making. So some basic stages are like training, signature evaluation and finally the decision making. The second one like in on software classification what we are doing, we know that it is done by the software only, we are just giving the classes, but some process are there or some steps are there like algorithm cluster data, then your pixel classification based on cluster and spectral class map are there, then finally we are getting a different class map. Then in post classification method, in post classification after classifying of the image, whenever we are getting a output of satellite image like it may be in a supervised classification, then what type of post classification classification करने के बाद हम क्या क्या follow करते हैं, in that you may have the image smoothing. In some cases you need to have a smoothing of the images for its like enhancement or for its better in visualization, we need to go for some smoothing exercise, and also we go for some recoding, maybe sometime it is required. Then जो मैं बोला था कि आपका accuracy assessment, in this slide you can see that like two columns are there, one is for classification result and another one is for ground truth collection. You can see that two columns like we are having different classes of forest, bush, crop, urban, open land, water and so on. In the right, in the upper side, that is in the classification column also we are having the same thing. So finally in forest is concerned, here we are getting a 0.83. That means 83% accuracy is there. But in a class called crop, it is like 0.58, or for say example, urban, we are having a 0.56 of the accuracy assessment. That means uh, uh, whatever classification is done by us, it is somewhat around like 56% it is accurate. So in that case, again we have to go for the classification and we need to clarify it whatever is possible. So ये जो है, these are some brief on like different type of classification things what you are going to practice. But my sincere advice is that before uh, having a idea on this theory, it's okay, but we need to practice more and more, then only you can get a good result when classification is concerned. सो आपका जो है ये इतना ही था आपका जो सिलेबस के हिसाब से। तो इसमें अगर किसी को कुछ डिस्कशन करना है तो कीजिए, अदरवाइज हम फिर सितंबर 11 को मिलते हैं। अभी कल से आपका सत्यरंजन गिरी जो है वो आपका जीपीएस का है क्लास, वो लेंगे, कुछ 4-5 क्लास है। देन वो आपका कुछ और कुछ टेक्निक इन रिमोट सेंसिंग है, जैसे डिजिटल इमेज प्रोसेसिंग जो हम अभी डिस्कशन किए ना, इसको और थोड़ा डिटेल में आपका सत्यरंजन गिरी जो है वो बताएंगे। जैसे अभी जो आज हम ब्रीफ में डिस्कशन किए, सुपरवाइज क्लासिफिकेशन क्या होता है, अनसुपरवाइज क्लासिफिकेशन क्या होता है, बट उसका और डिटेल में कैसे करते हैं क्या है, ये आपको इट विल बी टॉट बाय सत्यरंजन गिरी। एंड आई विल बी टेकिंग योर नेक्स्ट क्लास ऑन 11th September, which will be on spatial analysis and modeling part. Okay, then finally on 18th to 23rd September I'll be discussing about the application of remote sensing और geoinformatics. So आज तक का ये जो हमारा कितना 15 दिन का शायद, हाँ 15 डेज का जो सफ़र रहा, तो इसमें थैंक यू एवरीवन। एंड कुछ भी अगर आपको बोलना है तो आप आज बोलिए, और एनी टाइम तो हम ओपन है ही, अगर कुछ कहीं पे रिक्वायर्ड हो तो आप लोग हमको कांटेक्ट कर सकते हैं। हाँ भाई, किसको बोलना है कुछ तो बताइए।
सर थैंक यू सर फॉर योर काइंड सपोर्ट, थैंक यू सो मच।
हो गया तो एग्जाम में पास कर लोगे ना, 70-80% आ जाएगा, कोई दिक्कत नहीं।
बिल्कुल कर लेंगे, बिल्कुल कर लेंगे,
श्योर
सर बिल्कुल कर लेंगे, कुछ नहीं है सर।
ये होता है कॉन्फिडेंस, नहीं?
ठीक है सर।
चलो, और कौन है? ये एंड्रूज, डू वांट टू स्पीक समथिंग?
So I have one doubt, sir.
भैया क्या डाउट है?
Sir, what is the atmospheric correction?
See, in atmospheric correction, so many applications are there and so many techniques we are going to teach about it. But I can say that, see, for example, a cloud cover is there, na?
Yes,
So
sir.
that cloud cover needs to be removed. Otherwise, you are not going to interpret your satellite image in a accurate manner. So the process of removing the cloud can be an atmospheric correction. And along with that, suppose some haze is there, some haze correction can be done. And also in some cases, some noise is being produced by the sensor. तो उसमें उसको रिमूव करने के लिए भी यू कैन गो फॉर सम एटमॉस्फेरिक करेक्शन। और अगर आपको डिटेल इफ यू वांट टू वॉक, देन आई कैन से दैट जस्ट गो फॉर सम क्या बोलते हैं आपका आप जैसे ये आपका इमेज बेस्ड सॉफ्टवेयर है ना, ऐसे सॉफ्टवेयर इमेज प्रोसेसिंग बेस्ड सॉफ्टवेयर जो है, लाइक एडास और एनवी जो है, ENVI,
ऐसा ENVI,
तो इसका जो है आप यू कैन यूज दैट। एंड आजकल जस्ट गो फॉर यूट्यूब, यू कैन गेट सो मेनी like so many slides are there, so many videos are there, so you can go on that, you can you can work on that, because due to this time na, where
Yes,
actually
sir.
these all things are based on practical actually.
Yes,
So
sir.
practically we should learn it, and I hope ki Satyaranjan Giri is going to teach you about this all these techniques, because in your MGY 5 techniques in remote sensing and DIP is there. In that case, he is going to teach you in detail about this, how to do this practically. Okay,
Okay, sir.
but I can say that it's removing the scattering and absorption, जो कुछ effect रहता है. So we are just removing those effects on the image. Then we are having some different techniques, like it may be a dark object subtraction, we can do that. Then radiative transfer model are also there, then atmospheric model are also there. So and so many other applications are there. So by using those technique or application, you can remove these errors from the satellite image. Okay,
Okay, sir.
anyone?
Thank you, sir.
Yeah. और कुछ है तो बोलिए भाई, नहीं तो वाइंड अप करते हैं. आई थिंक कुछ नहीं है, तो चलिए. थैंक यू वेरी मच, और आप लोगों के लिए बेस्ट विशेस. चलो बाय.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.